Let's take a look at this chapter 19 through 21 review. Okay, so the first problem is, of course, a phantoms model, and you knew it was phantoms because it had asked you, is it significantly more defective? It gave you a level of significance. So those were the key reasons why you knew that you needed to do a phantoms model. And so a phantoms is a significance test. All right, so this was the proportion of computer components made that are found to be defective. All right, so and now, hey, if they had something like an incentive program going on, then you would want to add after the incentive program's in place. Okay. The null hypothesis was that the defective rate is still 0.07, and the alternative is that we're seeing if it is significantly more, so we're seeing if it has increased. Okay. Randomly selected computer components. I had quite a few people on the quizzes not putting the correct N right there. Furthermore, make sure when you do your large enough that you do N times true P, because we have true P given to us, not the P hat. All right, the normal model applies. Okay, one proportion z-test, and then there's how you got your standard deviation. You found your z-score is 1.7. Sometimes people ask me, how do I know which way to go on that? It's because you wanted significantly more. You were seeing if it was significantly more defective rate. So this p-value is low. On those chapter 20 quizzes I was grading, I had some people making a wrong decision. I mean, I don't know how much better to tell you, but if the p-value is low, reject HO. If it is not lower, then fail to reject HO. Here, we reject HO. So here's the conclusion. Since p-value is low, I reject that p is 0.07. And so, if you reject HO, you do have evidence of HA. So there is evidence to conclude that the proportion of defective computer components is greater than 7%. Okay, questions on number 1? Okay, number 2 is a panic. We have not done those in a while, so let's make sure you remember the computing on that. So this problem, P equals the proportion of shark attacks that occur, present tense, occur in deep water. Present tense, not past. Okay, we're making an inference about now and in the future. Okay, these were randomly selected sharks. Independent 200 is less than 10% of all shark attacks. Okay, this, because you do not have true P on this one. You do not have true P on this one. You're estimating true P. So that is why you are allowed to use P hat and 1 minus P hat on those.
So if you have the true P, then you use that.
Correct. If you have true P, that's the best it can be, and you should use that. The best it can be is if you use true P. If you don't have that, you can just use P hat. Okay? Now, the worst case scenario is those don't jive and you don't have either one, then what do? Use 0.5. Okay. All right. Normal model applies. This is a 1 proportion Z interval. Remember the name of this thing? Okay, now, the formula on the formula chart says, gives you this. Here is the formula, your statistic plus, I have it written here. Your statistic plus or minus your critical value, and that stems from, this is based on your confidence. So that's based on your confidence. Okay, and then you have your standard deviation of the P hats, which, of course, is that formula using the P hat because you don't have true P. All right. So yours may be a little off from mine because I bet you used 2.33 as your Z-score. If you used 2.33 as your z-score, what was your interval? Was it a little off from mine? What was it? Can you tell me how much it was off?
I got 0.04 to 0.099.
Really? Okay. 0.04. Okay.
0.039.
Okay. All right. I used the z-score 2.326 instead of using two significant digits, which you might have done. Hey, I noticed yesterday some people getting that z-score the wrong way. Even a strong student was doing that. So let's refresh. Make sure you used 2.33. Inverse norm of 1 tail. Do not go inverse norm of 0.98. That's wrong. That's like 2.05 something. So caution the z-star there, and this is going to mess you up on some multiple choice test questions if you use the wrong inverse norm. So caution, this is inverse norm of 0.01, not inverse norm of 0.98. Okay, important.
If it is two-tailed, you don't even, you're supposed to double the inverse norm after that.
Not on intervals. You double p-values in a phantoms in a test. There's no doubling going on here because we do not have a two-tailed hypothesis stuff going on here. Okay? All right, moving on. Okay, so let's take a look at this. I had lots of questions on what number 3A is asking. So basically what happened on 3 is this person took one sample and then was trying to make an inference about the whole entire population based on that one sample. So that's a no-go. See what I wrote here, 47% is just one sample. And you cannot represent the entire population from your just one p hat. You can make a range of values. For example, here's what we would say. We would say, I am 95% confident that the true proportion of whatever it is, U.S. women who say they don't have time for themselves is between 44 and 50. Now, how did I get this 44 and 50 nonsense here? How did I get that estimate, 44 to 50? Good. This number right here, I did 47% plus and minus 0.03. That's what gave me the interval from 44% to 50%. Okay, so that was my estimate. So an interval estimates a population value. All right, moving on. Number B says clearly explain what 95% confidence means. That's the confidence level. Okay? Now, you should probably, it would be wise, and I remember having a student a few years ago who was a struggling student or, I don't know, a slacking student or whatever, she struggled because she didn't do the work that she should. But she said, she studied really hard for this test, I remember her saying, and she said that she worked really hard at memorizing those songs. And at the beginning of your packet is those songs for this unit. And there's lots of definitions. And she said that totally saved her on the test because the multiple choice is filled with definitions. Okay? The multiple choice questions are very definition heavy. So make sure you have got those down. All right. So this was 95% of all 95% confidence intervals include the true proportion of the U.S. women who do not get enough time for themselves. Okay, C says the margin of error for the men was 4%. So the margin of error for the women was 3%. Was plus or minus 3%. Why was the men's larger?
Because women had more sample size.
Good. If you looked up in there, women's sample size was like 1,000 and something. What, 1,025? And the men's sample size was just 472. So this was more, men were more varied. And so therefore, they had a bigger margin of error. Okay, moving on. Number 4. All right. If you take a look at number 4 and you analyze the question carefully, here is the issue. This question had the confidence, the first part, the confidences were the same. So that was of no concern to you. The confidences were the same. So of those two sample sizes, n equals 25 and n equals 75, which one would be a longer confidence interval? The smaller one. A smaller n, remember, it makes a wider curve, so it would be wider or a longer interval. You know, if that was your p hat, then you would make your interval, and it would be wider with a smaller n. Okay? Now, let's look at part B. If you notice, part B has the same sample size. So n is the same, so that's not what it's going for there. The difference between these two was the 99% confidence versus the 90% confidence, and you can clearly see, if you look at a picture, 90% confidence is more narrow than a 99% confidence interval. So 90% would be smaller than 99% confidence. Okay? All right, questions on that? Okay, number 5 is like the quiz that we just had here, the reality. Okay, so this was about the farm. This guy, I don't know if you understand what's going on in this question. This question is, this guy is going to do a survey and see if the proportion of people that want Amy's ice cream or whatever is more than 40%. If that's the case, he will open up a new shop. So that's what's happening. So if it stayed 40%, he will not open a new store. If he has evidence that it is greater than 40%, then he will open a new store. So you can obviously see the benefit or the business issues related to getting an error associated with that. So type A, or question A, he thinks that people want the ice cream and he should open a shop when he really should not. The impact, he opens the new store thinking he will have a lot of business, but the reality is there was no improvement. Yes?
So, to actually answer that question, when it just says describe in words what the error would be, is that just the reality?
Yes, true. That's a good point. Yeah, technically all you had to do was put, because what it asked for was the reality and think. If it had asked for an impact, which I would imagine the test, would go into that, or I put that as a free response, then you would need to know that as well. Okay? Part B, type the reality is it is an improvement, or there a lot more than 40% of people want that ice cream, and so he should open the store. But he didn't detect that. So he doesn't open a new store, and he really did have enough business to support it, so he misses out on a new business venture. Okay, so people asked me this. This was a straight-up definition. Power, do you remember with your curves? There's the null hypothesis curve, and then you have the alternative hypothesis curve, and that, here is where type 2 error occurred. Beta was right here, type 2 error. And this is my alpha right here. And this was over in this region. This region had what? What's this region filled with? Power. Okay, good. So over here on this side is power. That is the ability to reject the null hypothesis if it is indeed false. And this is where your type 2 error was occurring. Well, what can you say about beta plus power? They equal 100% of the data. Yeah, 100% of the HA. So that's why you have this little formula. Power is 1 minus beta. Okay? All right, moving on. Number 6 was just another panic model. Okay, so number 6 was just another panic. The true proportion, you were trying to estimate from one sample the true proportion of fish caught in that lake that are inedible. You know, Trinity River, you're not supposed to eat fish from Trinity River because way back when Lockheed was Lockheed or General Dynamics, it was the bomber plant back in the 40s, and they dumped a lot of chemicals into Trinity River at that time, and so they say don't eat the fish out of Trinity River. But anyway, all right, random. We assume they were randomly selected fish. 80 is less than 10%. This is your sample size, 80, and notice. Okay, again, this is estimating P, so we have no true P because an interval estimates true P. That is why on panic model you can use P hats. On panic models you can use P hats. So it's a 1 proportion Z interval. Those are the numbers I got, and so I'm just going to leave that with you. You know, if you missed this problem, I think you should take a look at this inverse norm value. Okay, so if you got the wrong answers here, let's take a look at this. What was this? What was the confidence they wanted you to make? Oh, 99% confidence. If you want to be 99% confident, then you have 0.5%. That's 0.005 in each tail. Okay? So do not do inverse norm of 0.99. That's totally wrong. It's inverse norm of 0.005. That was so. Okay? So check that on that. Checking your critical value. All right. 7. Asked you to solve for n. It said, how large of a sample do you need? So I thought the wording on this one was a little strange. People didn't know what these numbers were. On number 7, it says, you want to assert with the probability of at least 9.95. That right there, asserting with the probability of at least 0.95, that's telling you your confidence level. So they wanted you to be 95% confident. And they wanted it to be the sample proportion differ by less than 0.06. That was your margin of error. Okay? So notice I used that formula, margin of error equals the critical value times that standard deviation. You did not have P, nor did you have P hat. So what in the world are you going to do if you don't have P or P hat? That's the one time you use 0.5, okay? And then I kept all of that stuff in my calculator so I wouldn't have all of the ridiculous rounding issues. I got 267 policyholders, okay? All right, moving on to number 8. Lots of people were asking me about this one yesterday, so let's take a look here. So, okay, first of all, I found that 89% of my statistics students turn in their homework on any given assignment. So this is a P hat. That is a sample proportion that I found, okay? My conclusion was based on a random sample of 180 students, so of course that's my sample size, and a margin of error of 4.2%, so margin of error is 0.042. So what confidence level did I use? So this one took this, you will be asked questions like this, so you need to know how to do this. I first used this formula that utilized margin of error, okay? And the goal was to solve for this critical value there. So do algebra. Do you see how I used algebra and I solved for that Z star? Okay, that was the first step. Once you solved for that Z star, then think of what that's saying. It's just also technically saying it's a plus or minus 1.8. So if you come over here, you got negative 1.8 and positive 1.8. Where is the confidence level? In the middle. Remember, they say be 95% confident. You put the 95% in the middle. So you are looking for this area in the middle. Well, I know the z-score bounds are negative 1.8 and positive 1.8, so I norm CDF'd from negative 1.8 to positive 1.8, and that's how I found out the confidence. Okay, moving on, number 9. Number 9, I'm not going to go in too much depth. It was a straightforward, use this formula and solve for n. So I'll let you look at that. Do keep in mind, I, in a previous year, went past more than 2 decimal places. Make sure the z-score you used, the critical value, was inverse norm of 0.01, not inverse norm of 0.98. Okay? Not inverse norm of 0.98. That's a common boo-boo. Okay. So, you know, somewhere this, if you had used 2.33, I think I'm going to go and when I do the test, especially on these kinds of problems, I'm going to go make sure that I do 2 decimal places on the z-score and that I make sure that the correct answer, or there's only one of them that's close to that correct answer, okay? I'll double check that and make sure that's there. Okay, moving on, number 10. Number 10 was a very simple problem if you understand the anatomy of an interval. An interval has this lower bound of, 0.532 and the upper bound of 0.628. P hat would be smack dab in the middle. What is P hat? Good, that's that sample proportion you got. So if P hat is smack dab in the middle, then you should be able to figure out what this right here is. This little section here is your margin of error, okay? So, there's lots of different ways you could do that. You could figure out what P hat is and then find that difference. I just found the total distance and then divided it by 2. So mathematically, there's lots of things you could do. The total spread is 0.096, so half of that is 0.048. Okay, now I have got to warn you against the most common wrong definition for p-value, because I guarantee you it will be a multiple choice option. Okay, you ready? So we know p-value is the probability of getting a particular sample result if the null hypothesis is true. P-value, this is the real definition. P-value is the probability of getting a particular sample result if the null hypothesis is true. Here is the most common wrong definition. It'll be on the test tomorrow. It'll be on the AP test. Here is a no-go. So this is a no-go. The wrong definition. P-value is the probability that the null hypothesis is true. That is wrong. P-value is not the probability that the null hypothesis is true. The p-value is the probability that you get a particular sample if the null hypothesis is true. All right, moving on, number 12. Okay, hey, and this goes back to also that number 4 on your quiz 21 you just had. Look here, they give you this interval from 0.793 to 0.851, and the claimed value was 0.86. So notice that 0.86 is not in the interval. So you have evidence to reject that 0.86. Okay, so that pretty much gives me an indication that the value, the proportion of cheddar cheese sales is going to be lower than 0.86. Okay? 13 was just a basic, don't you dare inverse norm 0.7. Okay, don't you dare inverse norm 0.7. It's inverse norm 1 tail, and there's 15% in each tail. Number 14. So, okay, this A is not 96%. Alpha, the rejection region, is 2% big. That is true. But you have to look at the alternative statement right here. This is critical. Look at that alternative statement to see how alpha is distributed. Is alpha all in one tail, or is it split between two? So because of this, alpha is split between both tails. So that puts 1% in the bottom tail and 1% in the top tail, thus 98% confidence. So had it been a one-tailed issue, then you actually would have had a 96% confidence, and I'm going to show you something related to that in a second. We can go ahead and suppose that right now. Let's suppose HA had been one tail. Then where would that put the entire alpha? That would put the entire alpha down here. Well, how do I get this confidence level? I need to mirror image it. And if I had this, then what would that make that? 96% confident. Okay? See that? Okay. All right. B. Okay, again, so what do you have to say about this point 2? Do you see how many times this shows up on the review? A lot. So I expect you to understand this. Since point 2 is in that interval, you do not have evidence to reject the null hypothesis. You would not end up, I would expect when I run a test, I would not reject. I do not have evidence of the alternative. Point 2 is a possibility. Can I say point 2 is true? No. Some people did do that on the quiz and I marked it wrong. Okay, moving on. Number 15, again, is the basics of understanding the anatomy of this. P hat goes in the middle. So you just found out what was exactly in the middle. Okay, number 16 is really important to understand. Here you are told the result, this will be like a test question, I guarantee. Statistically significant at the 10% level means the size of the rejection region is 10%. That means you found a sample that is at the very least in the top 10%. Okay? If statistically significant at this alpha of 10%. So you are in the top 10% of your class. Think about it that way. Well, then does that mean you are definitely located in the top 5%? If you're in the top 10% of your class, are you in the top 5% of your class? Not necessarily. So that's what I have written over here on this side. If you are statistically significant at 10%, that means you are in the top 10%. If you are in the top 10%, are you in the top 5%? Not necessarily. So you are not significant at 5%. But if you are in the top 10%, are you in the top 20%? Yes. So you are significant at the top 20%. All right. 17 just asked you for that margin of error formula, but let's look at 18. 18 is similar to that number 15 we were talking about a minute ago. Okay. So, number 18 asks, what is the critical value? This is a vocabulary thing. If you remember, critical value is a Z star. Okay. So, and alpha is 0.12. What does that mean if alpha is 0.12? That is the what? The size of your rejection region. Okay. So then, after assessing that, to do part A, you must look at the alternative. This alternative is a one-tail upper tail. Therefore, the entire alpha is located in the top tail. If the entire alpha is located in the top tail, this question is asking for the Z star right there at that location, and that would be inverse norm of the area below. Inverse norm of the 0.88 is the Z at that spot, and that would be 1.18. Okay, look at part B. B says the alternative is having that less than 0.4, the lower tail, the entire rejection region is in the lower tail. So 12% is down there. Okay. So then to get this z-score right here, I'm going to do inverse norm of the 12% below, and that is a negative 1.18. All right, and the final one is different because it takes the rejection region, the 12%, and it distributes it amongst both tails. Since it distributes it amongst both tails, it puts 6% in the lower tail, 6% in the upper tail, so you have to recalibrate these critical values here. This lower critical value is the inverse norm of 0.06, so that's an inverse norm of 0.06, negative 1.56, and you know, I know by symmetry that this is the positive version of it, which you could do inverse norm of 0.94, and that would give you that. Okay, so what I'm telling you on this test is that this review is pretty straightforward. It does not have tricky stuff on it. Okay, this is not tricky stuff. You need to understand every single thing on this review. I will be testing you on all of these ideas and all of these components, and furthermore, make sure you either sing or you hum or you look over, you memorize the songs, because those definitions will be tested as well.